Welcome to Prompt Pumpkin Studio, where our goal is to help you become AI literate and AI savvy. Let's just be honest for a second. If you're a Python developer working with LLM APIs right now, chances are your AI agents are basically duct taped together with custom, super fragile APIs, right? I mean, you probably spend hours writing rigid integrations just to get your AI to read a simple file or run a basic database query. It's exhausting. But what if there was just one single universal standard? Well, today in this Masterclass Explainer, we are going to completely demystify the Model Context Protocol, or MCP. It is literally the USB-C for AI. One standard for any model to connect to any tool. We're going to take you from first principles all the way to actually building your own custom Python MCP server, and we'll outline the critical testing patterns and gotchas you absolutely need to know. Okay, let's take a quick look at our syllabus for today. We'll be covering AI's missing link, the USB-C analogy, the core architecture, real-world workflows, building a Python server, and finally, security and the future. Let's get into it.
Section 1, AI's missing link, bridging the gap.
So let's acknowledge the massive elephant in the room that developers are facing right now. We all know AI models are unbelievably powerful at reasoning, but out of the box, they're totally isolated. They can't see your local workspace, they can't touch your production database, and they definitely can't access your internal company APIs without you writing a ton of manual, repetitive glue code. Pre-MCP, it was pure chaos. If you wanted Claude or an OpenAI agent to interact with GitHub, Slack, and your local file system, you had to write 3 completely different, hard-coded integrations. Total maintenance nightmare. But the unified MCP vision, it changes the game completely. It introduces one standard JSON RPC 2.0 protocol. So now any client, whether that's your IDE, a custom agent, or a chat app, can talk to any server seamlessly. Actually, there's this great quote from Active Pieces that perfectly captures the massive shift we're seeing right now. Give a person AI alone, and they'll only get answers. Give them access to MCPs, and they will use those answers to automate tasks for a lifetime. And that's the whole point, isn't it? It's the crucial leap from an AI just acting as a conversational chatbot to an AI functioning as an autonomous agent, taking actual, meaningful actions in your local files and databases. Moving right along to Section 2, the USB-C of AI, universal connectivity. Think back to the dark ages of electronics before USB-C came along. You remember that, right? Every single device required a different proprietary charger. You probably had a messy drawer just full of tangled cables. Well, MCP replaces those messy individual integration cables with a single universal port. The AI sits on one side, your tools like Gmail, Drive, or Slack sit on the other side, and MCP acts as the secure, standardized bridge right in the middle.
So to give it a formal definition, the Model Context Protocol is an open standard introduced by Anthropic. It allows AI assistants to securely and dynamically connect to local tools, databases, and APIs without having to write all that custom glue code. And because it's an open source protocol, every major AI lab and tool provider is currently adopting it, which is building this massive interoperable ecosystem.
All right, Section 3, core architecture and primitives. To really wrap your head around this, you need to understand that in this architecture, your client, like Claude Desktop or Cursor, is basically the thinking side, while the server provides the actual capabilities. And the client actually introspects these servers dynamically. This all comes down to 3 core primitives. First up, we have tools. These are essentially JSON in, JSON out remote procedure calls that have real-world side effects. Think executing a SQL query or running a Python script on the fly. Second, we have resources. These are read-only URIs that ground the model with raw data, like pulling in your local markdown files. This is absolutely vital for reducing AI hallucinations because you're feeding it actual facts. And third, prompts. These are versioned, server-side templates shared across clients. So imagine a parameterized bug report template that lives on the server, saving you from rewriting your instructions every single time. Now you might be wondering, why not just use regular REST APIs? Well, what makes MCP outshine traditional REST APIs for agentic workflows is how it replaces rigid schemas with dynamic inspection. Instead of hard-coded plugin integrations, MCP brings 4 massive wins: discovery, consistency, portability, and security. The AI client literally interrogates the server and says, "Hey, what tools do you have available for me right now?" It's brilliant. It moves engineering teams away from scattered, bespoke plugins and into a totally coherent, standardized AI tooling layer.
Section 4, real-world developer workflows.
So how do these architectural concepts actually manifest in usable workflows for your day-to-day dev environment? Well, whether you're managing PRs, querying SQL dashboards, checking ops logs, or doing web scraping, there is already an MCP server for you. The sheer power of the existing ecosystem is crazy. You can plug in the GitHub MCP server to let your AI review code and manage PRs directly. Connect the Postgres server so the AI can explore schemas and write complex natural language SQL queries for you. There's the Microsoft Learn Docs server to ground your agent in real-time authoritative API references. You can even use Playwright for autonomous browser testing, or the File System server to let the AI safely navigate and edit your local project directories. It's a total game changer. And getting these pre-built servers up and running is ridiculously fast. Step 1, you just locate your mzp.json configuration file in an IDE like Cursor or an app like Claude Desktop. Step 2, you append the server details. You specify the execution command, like npx or Python, and provide the absolute path to the server. Step 3, define your environment variables for any authentication tokens, because you definitely don't want to hardcode secrets. And Step 4, simply restart your AI client. The client reconnects, introspects the new tools automatically, and boom, it instantly gains those capabilities. Section 5, building your own Python server. Let's get our hands dirty. Look, using existing servers is fantastic, but building your own custom Python server is where you unlock true superpower status. We're going to build one using the FastMCP approach. Conceptually, it's just installing the SDK, defining tools as decorated functions, registering resources, and starting it up. Step 1, initialize your project folder, maybe using something like uv-init. Step 2, install the official MCP Python SDK via pip along with HTTX from handling asynchronous requests, which is perfect for when we build, say, a text summarization tool or fetch dynamic markdown. Step 3, create a main server.py file. This is where the whole shebang lives. Inside that server.py file, Step 1 is defining the server instance itself, giving it a name like productivity server. Step 2, you're going to use decorators, specifically @server.listtools, to expose your capabilities to the client. Now, Step 3 is a massive pro tip. You absolutely must define the tool schema with incredibly descriptive names and parameter explanations. Think of this as your new prompt engineering. The LLM reads this description to decide if it should actually trigger the tool. If your description is vague, the AI is just going to ignore it. Now, to handle the actual logic, Step 1 is using the @server.callTool decorator. This routes the AI's request directly to your Python function. Step 2, ensure everything is fully asynchronous. MCP is built entirely for concurrency, so you absolutely have to use async and await for any data fetching or I/O operations, otherwise you'll block the whole process. Finally, Step 3, start the server using the standard input/output or STDO transport layer. This is literally how the JSON RPC messages flow back and forth between the client and your server. Okay, pay attention here, because when you're building these, you have to follow some crucial debugging patterns. Always start by testing just one single tool to verify the connection. But most importantly, and I cannot stress this enough, never use a standard print statement in your Python code for debugging. Seriously, don't do it. Because MCP communicates over standard input/output, a stray print statement will immediately corrupt the JSON RPC payload and break your entire server. No way around it. Instead, use built-in logging modules and write your logs to a separate local file. Also, always return structured errors so the AI knows how to recover gracefully, and remember to restart your client app whenever you tweak the server code. And finally, Section 6, Security and the Future. We've talked a lot about how powerful it is to give AI agents access to your files, APIs, and databases. But obviously, with great power comes the need for serious responsibility. You really have to ask yourself, if your AI client can autonomously execute tools and write to databases, what is the actual blast radius if things go wrong? Or worse, what if an untrusted prompt manipulates your agent? You have to treat an MCP server deployment exactly like a serious production backend deployment. The blast radius is very, very real. To mitigate that risk, you must follow these best practices relentlessly. First off, never hardcode API keys directly into your scripts, period. Use least privilege tokens exclusively via environment variables. Also, if your tool does something potentially destructive, like dropping a database table or sending a public email, you need to ensure the client requires explicit user consent before execution. Put a human in the loop. And of course, implement strict server-side policy checks, validate exactly who is making the request, and maintain comprehensive audit logs. So, to wrap this all up, we are witnessing a massive industry shift right now. We're moving from bespoke, hard-coded API scripts to standardized plug-and-play MCP ecosystems. We are heading straight toward a future full of MCP marketplaces, first-class agent framework support, and true internal AI operating systems where your AI just flows seamlessly across all your enterprise tools. The only question left is, what custom Python server are you going to build first to accelerate your workflow? Let me know down in the comments, and we might even feature it in a live build follow-up. If you enjoyed the video and learned something new today, make sure to hit the like and subscribe button along with the bell icon. Be AI literate, be AI savvy. See you in the next one.